Hello guys, I'm working on this prototype here. It's meant for a push-pull VTTC setup, opposed to the traditional single-ended VTTC design. This one is kind of unique about that it doesn't use a feedback coil. It has a single primary coil. You can ignore this coil right here. It's remnant from another experiment, but it's not connected anywhere. You can see the wire right here. That coil attaches. It's not connected anywhere, and these resistors are tied here to ground, so they're not going into here. So there's no trickery going on. It's just this coil. I'm using a very small tube. This is a QQE 025. It's a double Tetrode designed for some high frequency oscillations and modulations for small transmitters, I suppose. It's a very small power tube. It's 5 watts per plate, and since there's 2 of them, it's 10 watts in total. I'm stressing this tube quite hard. So the way this is constructed, it's basically set up as a multi-vibrator, and with a primary coil and a resonant capacitor. It's using a central tap primary. The central tap goes through an RF choke over to the B+, and the B+ also powers a screen grid, because the screen grid in these two tetrodes are shared. It's technically not just a pure tetrode. It's technically a beam tetrode, since there's also like a beam electrode in there. This is the schematic right here with all the design values. 1 nanofarad might be a bit overkill, and the 100 ohm, where is it? Oh, I forgot to draw the 100 ohm in. So yeah, there's a 100 ohm resistor powering the 2 screen grids, and that is too low. The screen grids get a bit too much voltage. According to the datasheet, 116 volts is still fine, but it depends on a whole lot of different factors. So yeah, I'm overdriving the screen grids. They are partly glowing. The secondary resonance frequency is 115 kilohertz. The primary frequency is a bit off because I put 2 3 nanofarad capacitors in series, and they were all a bit overachieving on the actual capacitance. So I'm not getting half 3.3 nanofarads. I'm actually getting 1.867 nanofarads, and so the tolerance in the primary inductance, it's not hitting the correct frequency. But even still, it's fairly powerful. You could easily scale this up to bigger power tubes like the GU81 M over there, or the standard GU81 would also work fine. So yeah, I'm a bit concerned about the negative voltage on the grid, independent because of the distance, but it's probably not enough to arc. I'm mostly concerned about the isolation, because there's no isolation from one anode to one grid. So if, let's say, this capacitor broke down, this grid is getting full B+ essentially through the DC resistance of the coil. So if I was building this with bigger tubes with bigger power levels, like an actual vacuum tube Tesla coil over there, I would probably use 2 doorknobs in series, rated for, like, I don't know, 30 kilovolts or something like that. It just seems appropriate. So yeah, this actually works. And I also have a radio frequency choke right here. It's just any choke, really. I mean, this one was harvested out of a UPS, I think. So yeah, the tube's been heating up. Let me show you the waveforms. The scope is already attached. Let me turn on the scope. Okay. So the bottom trace is one grid and the top trace is the other grid. So as you can see, wait, hold on, let me lower the voltage a bit. Yeah, okay. So you can see there's a phase shift I want. 180 degrees or something like that. So when one tube is shut off, the other one is conducting, and we can see that perfectly here. So it's actually push-pulling, which is great. I had to reduce the power supply voltage a bit because one of them is a ×10 probe and the other one is a ×1 probe. And ideally I would have two ×10 probes. When I got this oscilloscope, I got 4 old probes for it. One probe died like a few days after using it, like the cable just broke. The other one broke a week ago, and now I just have 2 probes left, and there's this nice Tetronics one and this ×1 probe. This is ×10, this is ×1 probe. They're not settable. Like they don't have the switch on them to switch between ×1 and ×10, so they're just fixed probes. So yeah, I have to reduce the voltage a bit to make the voltages still appear on the scope screen. So yeah, it's oscillating, and it's slightly not enough. It needs a bit more voltage to turn on. Yeah, there we go. It turns on. It's actually fairly powerful. Let me put the back on. Let me put this to maximum. Turn this supply on. You see that the scope screen goes over the maximum. You can see that it's fairly bright. The maximum brightness, of course, right about to touch the top load. When I touch it, the brightness decreases a bit. Over here is the maximum. So yeah, it's pretty powerful. You can light a tube up almost like to the edge of the table. The thing is, I'm not sure if you can see it. Yeah, you can see it. Grid 2 of the tube is glowing, as already mentioned before. But this setup seems to work pretty good. I mean, could be. I mean, this is drawing like 10 watts. This whole setup here is drawing 10 watts. The filament is excluded in the measurements, otherwise it would be 13 watts. But for 10 watts, this seems pretty okay. Specifically, was the resonance frequency is off by, I think 100 kilohertz or 50 kilohertz or something close to that. I can draw some small arcs of it, like 1.5 millimeters, something like that. So yeah, there is some power behind it, but it's not very good because it's obviously using a small tube. It's obviously not using high voltage. The high voltage is 120 volts DC, made from 2 60 volt supplies in series. Is there anything to improve? I mean, there's a lot of things to improve. For example, use a better tube, more voltage, a better secondary, because this one has a few breaks in the wire because I used 2 spools of not long enough wire, better primary capacitors, and of course get rid of some old remains. This coil is, you see, it's not connected anywhere. Like this old feedback coil is not connected anywhere. But it works, and I'm proud that I got it working. I was originally trying the Push-Pull VTTC with a center tapped feedback coil and 2 individual grid leaks, and it did work to some extent, but there definitely was problems with parasitic oscillations between the two, because I think I had to do something with matching the 2 tubes inside there, or something close to that. I'm not exactly sure. In my mind, this would work, but it doesn't seem to work really well. I mean, one tube is basically, one half of the tube is basically doing the correct oscillation. The other one is like sort of helping with a bunch of a bunch of high frequency oscillations. I also added an RF trap to this, and didn't seem to have changed anything really. There's a big problem with parasitics when you have another coil. I don't deny that it is not possible to do it like this, but I haven't managed to do it. To anyone who's watching, I'm calling for someone to experiment with this design and actually get it to function, because in my mind I don't see why it wouldn't work. Yeah, this is the kind of thing I mentioned. So this wave, I mean, I got it to work eventually, but it was really touchy. Like, these probes would influence the signal by a lot, and I would do some special setup. Okay, for example, like this one, I'm leaving a lot of noise out of this thing. This side of the tube was basically doing the parasitic oscillation, and this one was actually doing the real oscillation. And this one is like way tinier, this one way larger. So there was like high frequency waveforms imposed on that. So yeah, the second tube did help, but it was not perfect. So I think it could be a connection problem on my end, or some other reason why it didn't work. Maybe the tubes in there are badly mismatched. I don't think that they're badly mismatched, because the waveforms on the scope looked pretty much identical in amplitude, maybe like 5% off, something like that. But that was like this one of them was 30 volts peak to peak, and the other one was 8 volts peak to peak. So this one was 8 volts peak to peak, and this one 30 volts. So you see a greater difference there. So yeah, this once again the current design. Yeah, so I should probably shut the scope off. Yeah. Thanks and bye.